In section 4, we will cover a task that involves a learning method with a completely different philosophy than what we've seen so far. OpenAI Gym is a professional visual environment for developing and testing reinforcement learning algorithms in TensorFlow. In this section, we will leverage TensorFlow's reinforcement learning library, TF Agents, to achieve state-of-the-art results on a Pac-Man environment. We will focus on a strong understanding of the algorithms and grasp their underlying details with a practical approach. In this video, we are going to introduce reinforcement learning. Reinforcement learning is different than what we've seen until now. So far, we've only done supervised learning. Supervised learning is when we give an algorithm a set of features and tell it what it should learn from it. Associated values, classes, or text to generate. In reinforcement learning, however, we don't do this. Here, we have an environment in which the algorithm can take certain actions. Depending on the actions it takes and their results, the algorithm will get a reward that tells it how well it did. This makes learning a lot harder, but also a lot more powerful, since we will force our models to learn how to maximize their reward, thus making them a lot more goal-oriented and useful in many more fields. Some examples of powerful reinforcement learning applications are AlphaGo, which defeated world champions at the game of Go. This game has many more possible moves than even chess does. While chess has had algorithms that could easily beat top players for many years, Go remained untouchable by computers until only a few years ago, when a reinforcement learning-based algorithm, developed by Google, defeated the world champion. Intuitively, it is easy to see how reinforcement learning could be applied to game playing. If the model wins a game, it gets a positive reward for its good moves. Otherwise, it gets a negative reward. This also has the advantage of basically having infinite data available for training, because the algorithm can simply play against itself. It also has applications in medical research. Consider the problem of finding drugs that work well against a virus or bacteria. These interactions can be simulated, and good results can get positive rewards. While math-heavy and highly theoretical in general, TensorFlow makes reinforcement learning easy to use, as we will see in the upcoming videos.